Shake Table Lab by Courtney Walls and Gretchen Lundberg. Before we started building, we sketched a plan for our structure so we would know how to build our tower. Connecting straws on the first story of our building to make the first story stable and tall is what we are doing. We are getting ready to work on bracing the second story so our building can support the weight of the sandbags. Mr. C gave us advice on how to build our structure so it wouldn't fail. Taping the paper floor to our first story is important because it helps support the weight of the sandbags. The dimension of the base of our building is 20 centimeters by 20 centimeters, and the height of our building's first story is 20 centimeters. The height of the second story is 19 centimeters. Our building has a total height of 39 centimeters. When we tested our building, it supported 4 sandbags, 2 on the first story and 2 on the second story. We put braces on the sides to make them stronger. We also put a lot of tape on the places where the straws connected to make sure they stayed connected. This is one of our building's strongest parts because it connects together, which strengthens the base. The weakest part of our building was the bottom section because we did not have enough straws to support the weight of the sandbags. We tied the string on the top layer of our structure to add more support and to make sure the straws didn't bend. We used the tape to secure our structure to its base. We also used it to connect straws to our building and to make sure our braces had support. If we had 5 extra straws, we would place them going up throughout the structure to help it support more weight, and we would also use them to help make the 2 floors more stable. This was a sensor reading for a building that failed on the major earthquake when it held 4 sandbags. The green line represents the forward and backward motion of the shaking, and the orange line represents the side-to-side motion of our building. The blue line represents the bouncing motion of the building. Hi, I'm Gretchen Lundberg, and I am here to talk about my building project. My partner is Courtney, and we built a building that supported 4 sandbags. And our building failed definitely at the base because we didn't have enough support with the braces to support the weight of the sandbags. If I was going to change anything about my structure, I would definitely add more straws to help brace it and help the floors support more weight. What I learned about building strong earthquake-proof buildings is that you need to have a strong base if your building is going to support weight. And I really liked the project because I thought it was fun how we actually got to build our own buildings. Thank you.
Hi, my name is Courtney Walls, and I'm here to talk about my building lab project. My partner is Gretchen Lundberg, and our building supported 4 sandbags. Our building definitely failed at the base of the building because there wasn't enough support from the braces to support the weight of the sandbags. If I were to change a part of my building, I would have definitely added more straws to make stronger braces to support more weight from the sandbags. What I learned about building strong earthquake-proof buildings is that you definitely need a strong base of the building or else it'll just fall over like ours did. What I liked about the building project is that I thought it was so cool that we got to make our own buildings and test it like there's actually a real earthquake. Thank you. Bye.
Thanks for reading. Bye.